Good morning, dear students. Today, inshallah, we will start talking about lesson 3. And in lesson 3, we will talk about the metallic and non-metallic properties. We have mentioned at the beginning of the 19th century that a scientist called Berzelius was the first scientist to classify elements into two main groups, which are metals and non-metals. And this was according to their physical structure and physical properties. Indeed, that was before knowing anything about the atomic structure. With the development of our concept about the electronic structure of atoms, we can now differentiate between three groups of elements. These three groups of elements are metals, non-metals, and metalloids. Let's start talking about metals. The metals are the group of elements whose valence shell has less than half its capacity of electrons, which means that their outermost energy level has less than 4 electrons, as the capacity of the outermost energy level is 8 electrons. So having less than half the capacity of the outermost energy level, which means less than 4 electrons in the outer shell. So we can say that they lose electrons of the valence shell, since they are less than 4 electrons and less than half the capacity of the shell. They lose these valence electrons to reach the structure of the nearest noble gas. Consequently, metals form positive ions, and hence they are described as electropositive elements. Their good electric conductivity is attributed to the mobility of their few valence electrons. So we can say that they're good electroconductors or good conductors of electricity due to the mobility of their few valence electrons. They have a few number of valence electrons which have high mobility, which can transfer from one position to another in the metallic structure. Metals are characterized by their large atomic radius, which leads to small magnitudes for ionization energy and electron affinity. The second type of elements is the non-metals. The non-metals is the group of elements whose valence shell has more than half its capacity of electrons. So the non-metals have more than 4 electrons in the outermost shell. They form ionic compounds when reacting with metals by gaining a small number of electrons to reach the structure of the nearest noble gas and form negative ions. So when a metal reacts with a non-metal, they mostly form ionic compounds, and this is because metals tend to lose electrons of its outermost energy level. Metals tend to lose their valence electrons when entering a chemical reaction, and non-metals, on the opposite, tend to gain electrons to their outermost energy level, and both reasons is to reach the nearest the electronic structure of the nearest noble gas. So we have the metal losing one or more electron and forming positive ions, and non-metals gaining one or more electrons and forming negative ions. So the presence of a positive ion and a negative ion means that the presence of an ionic compound. Thus, non-metals are described as electronegative elements. Nonmetals, of course, are bad conductors of electricity. They do not conduct electricity. Because their valence electrons are strongly bound to the nucleus. They have a large number of electrons in the outermost energy level, so the mobility of the electrons is low. The electrons have low mobility, and in nonmetals we can notice that they have small atomic radius and high nuclear charge, large effective nuclear charge, so the electrons are strongly bound to the nucleus. That's why they have no mobility. So it's difficult for the electrons of the outermost, the valence electrons of a nonmetal to be transferred from an energy level to another. Therefore, nonmetals can be used as insulators, as electric insulators, as they're non-conductors of electricity. And as we said, that nonmetals have small atomic radius that leads to high values of ionization energy and electron affinity. The third type we will talk about is the metalloids. The metalloids are a group of elements that have metallic appearance. They look like metals and the most of the properties of nonmetals, but act mostly like nonmetals. So we can find that the electronegativity of metalloids is intermediate between metals and nonmetals, which means that the electronegativity of metalloids is higher than that of metals but lower than that of nonmetals. Their electric conductivity as well is also intermediate between metals and nonmetals. So they are not very good conductors of electricity such as metals, and they are not electric insulators such as nonmetals. But we can say that they are semiconductors of electricity, and that's why they are used in the manufacture of some electronic instruments parts such as transistors or electronic chips. And that's because metalloids are semiconductors of electricity. Now let's talk about the graduation of metallic and non-metallic property in the periodic table. We can notice from the opposite diagram the position of metals, metalloids and non-metals in the periodic table. So we can notice, of course, that most of metals are present in the middle and the left hand side of the periodic table, while non-metals are found at the right hand side of the periodic table, while metalloids lie in between metals and non-metals. So we say that in periods, as we move across a given period from the left to the right, we observe that the first group includes the elements of the highest metallic character. So, as we move from left to right in a given period in the modern periodic table, the first group includes elements of the highest metallic character. Then the metallic character gradually decreases in the period until we reach the metalloids. To the right of the metalloids begins to appear the non-metallic character until we reach group 7A, the halogens, which include the elements of the highest non-metallic character in the periodic table. And to the right of the halogens, of course, we can find the noble gases. While in groups, on descending down a given group, the metallic character increases with the increase in the atomic number as we go down the group. We conclude that the elements of the strongest metallic character are placed at the bottom on the left hand side of the table. Of course, as we go down the group, we can notice that the atomic size or the atomic radius of the atom increases and the effective nuclear charge decreases due to the screening effect and the appearance of extra shells, extra energy levels, and the screening effect of the inner field energy levels. So the metallic character increases as we go down the group. That's why the elements of the strongest metallic character are found at the bottom left of the periodic table. Thus, cesium is considered as the element which has the highest metallic character in the periodic table. On the other hand, the elements with the highest non-metallic character is found at the top of the right side of the table. The non-metallic character decreases as we go down the group, and that's also attributed to the increase in the atomic size and the decrease in the effective nuclear charge. And the non-metallic character depends on the effective nuclear charge. So on ascending down a given group, as the atomic radius increases and the effective nuclear charge decreases, so the non-metallic character decreases. And that's why the elements with the highest non-metallic character is found at the top right of the periodic table. Thus, fluorine is considered as the element which has the highest non-metallic character.